The content in this video will be showed how to DIY an easy-made DC 2V to DC 30V adjustable power supply, step by step in details. This is a digital voltage regulator with input DC 4V to 40V, output DC 2V to 36V, maximum 8 amps capacity. XL4016 is its basic component for this device, which is similar to ML317. However, it has more functions than ML317. This is the input DC terminals. That is the output DC terminals. And digital voltage meter is here. This is a 20k ohms mini adjustable resistor. Due to its small size inconvenience in practical situation, a potentiometer like the one here will be used. So the small one will be removed. By desoldered. Then carefully removed it. The resistor just removed is 20k ohms. However, this potentiometer is 50k ohms. A resistor with 33.33k ohms can be chosen to be connected in parallel with a 50k ohms potentiometer. So, their ohm values combined will be 20k ohms. Let me explain it in details. As we know in parallel connection, a formula for combined resistor value is 1 over R equals 1 over R1 plus 1 over R2. Filled the actual ohm values into the formula. 50k ohms is for the potentiometer. 20k ohms is for the resistor removed. R2 is the resistor's value, which we need to know. Then R2 equals 50k ohms times 20k ohms over 50k ohms minus 20k ohms, approximately equal to 33.33k ohms. So, chosen a 33.33k ohms resistor to connect it with a 50k ohms potentiometer in parallel. We'll get the same ohm value as 20k ohms as the ohm value of a resistor removed. A 33.33k ohms resistor will be soldered on between the terminal pins on a potentiometer. By using a multimeter's ohm position to check this resistor's ohm value, it is 33.4k ohms. All good indeed. That resistor has been soldered on the potentiometer's two terminal pins, which they connected with a resistor in parallel. Still using a multimeter's ohm position to check a potentiometer's combined ohm value. You see, it is 19.9k ohms. And almost the same as a resistor removed, as 20k ohms. The potentiometer has been modified and ready. This bracket, which made by DIY, is for the potentiometer. The green and gray wires have been soldered on the holes where a 20k ohms resistor removed. The gray wire is for the ground. The parts, or components, will be secured on a wood board here. Here we go. All done. These are DC input terminals. Those are DC output terminals. The output negative terminal is here. The output positive terminal at the bottom. A combined potentiometer is here. 2 wires have been soldered on the potentiometer's 2 pins. The mini digital meter is for the output voltage. This is a modified power supply, which its input is AC 110 volt, or 220 volt. The output is DC 33 volt, and maximum 10 amperes. This is live wire. That is neutral wire. Earth wire is here, which is from the largest pin on the power plug. This gray wire is the DC output negative. Brown wire is the DC output positive. Double sides glue tapes have been installed underneath the wood for sticking with the power supply together. Positive wire from the power supply goes there, and negative wire from the power supply goes here. All in one piece now. The range of the output of this adjustable power supply is DC 2 volt to DC 30 volt. These 2 wires are for the regulator's DC input voltage. The AC power is ready, but it has been not switched on yet. Switched the power on. The power supply's indicator is on, and so is the voltage regulator's indicator. The 2.65 volt is the DC output voltage now. However, the 1.60 volt is the lowest DC output voltage. Continuing adjusting until reaching at the top end. The 30.5 volt is the highest DC output voltage. I will connect a bulb for load testing at this voltage level. Green wire from car's bulb has been connected to the regulator's DC output positive. Black wire from the bulb connected to the regulator's DC output negative. Switched the power on. A bulb's DC voltage is 14.2 volt. Continuing lowering the voltage. At the 3.16 volt, a bulb is still lighting. At the 1.65 volt, a bulb is very dim. However, regulator's indicator is almost out, but the power supply's indicator is still okay. A multimeter's 10 amperes position has been selected to check the current goes through a bulb when varying the output voltage. DC positive connected to green wire from a bulb. Black wire from bulb connected to red probe from multimeter. Black probe from multimeter connected to DC negative. Switched the power on. 2.61 volt indicated. The bulb is dark. 0.76 ampere indicated by the multimeter. The voltage increased to 5.32 volt. The bulb got bright, and the current reached to 1.06 amperes. The voltage increased to 9.18 volt. The current reached to 1.41 amperes, and a cooling fan worked automatically. The voltage increased to 12.3 volt. The current reached to 1.64 amperes, and these are the bulb normal operation condition. The voltage increased to 14.1 volt. The current reached to 1.77 amperes. That's it. Now you've known how to make an adjustable DC 2 volt to DC 30 volt and maximum 8 amperes power supply. Thank you for watching. Please like, share, comment, and subscribe if you have enjoyed the video. Your encouragement is my motivation.